Chapter 2, Lesson 1, we're going to finish up this lesson looking at converses. And we've been looking at conditional statements. And converses are conditional statements as well that take an original statement and manipulates the hypothesis and conclusion, meaning this. The converse of a conditional simply switches the hypothesis with the conclusion. So you take what was the hypothesis and you make it the conclusion, and you take what was the conclusion and you make it the hypothesis, and that will be your converse. So converse simply switches the hypothesis and conclusion. In mathematical notation we had if P then Q. The converse would then say if Q then P. Alright? In example 5, both the original and its converse are true, and it is possible, however, for a conditional to be true and its converse not to be true. So it is possible for a conditional and its converse to have different truth values. And this has very important consequences when it comes to logic and reasoning, because in many cases many people will switch the hypothesis and the conclusion, thus making a converse, and say, well, if the conditional was true, then the converse, or what I'm saying, is also true, and that's not necessarily the case. So it's a mistake in logic to automatically assume that if a conditional is true, its converse is also true, because that's not always the case, and we'll look at a few examples here. So let's take a look at some examples where we can have to determine whether the conditionals are true or false. So let's take a look at this first conditional. I get it out here. And the first conditional says right over here, if two lines do not intersect, then the two lines are parallel. Is that true or false? Again, if you want to show me it's false or prove it's false, you have to give me an instance where two lines do not intersect. You have to meet the condition, but then you give me, you show that those lines are not parallel. And actually, this is false because we know that two lines that intersect could be skew. So that would be two lines that do not intersect, meeting the condition. However, the conclusion is different. So this conditional would be false. However, if we take a look at the converse of this very same expression, so let's take a look at its converse, where we switch the hypothesis and we switch the conclusion. So we say if two lines are parallel, then the two lines do not intersect. That switched the hypothesis with the conclusion. And in that case, the converse is true, because if two lines are parallel, then they do not intersect. So here was a case where the conditional was false, but its converse was true, so the truth value was different than with the original. Let's take a look at another one. If you travel from the United States to Kenya, then you have a passport. Is that a true or false conditional? Well, that would be true, because you can't leave the United States or get into the country of Kenya without a passport. So if you traveled from the United States to Kenya, then you would have a passport. So let's write the converse of that, which means we're going to switch the hypothesis and conclusion. So if we switch that, we'll say if you have a passport, then you travel from the United States. Now, is that true? Well, no, that's false, because you could have a passport and never leave the United States. You could travel from California to Nevada, and that doesn't require one. So while you have a passport, that doesn't mean that you travel from the United States. So this conditional, or its converse, would be false. So again, we demonstrate that the conditional and its converse may have different truth values, and that's okay. So let's take a look at one more example. If a substance is water, then the substance chemical formula is H2O. Now that would be a true statement. If you have water, you have H2O. So let's look at its converse. So we'll switch the hypothesis and the conclusion. So if the substance chemical makeup is H2O, then the substance is water. Is that true? Well, that's true as well. So in this case, both the conditional and the converse had a truth value that was the same. They were both true. But as we've shown, that's not always the case. Well, let's do one more example for you. So here's one more example. If two angles measure 90 degrees, then the two angles are congruent. That is true. If they both have the same measure, then they would be congruent. Okay, so let's look at the converse of that. If two angles are congruent, then the two angles measure 90. Well, that's not true, because you could have two angles that are 30, or two angles that are 45, or two angles that are anything other than 90. So just because they're congruent doesn't mean that they have to measure 90. So I hope that demonstrates for you how you can, the fact that while you can write the converse by switching the hypothesis and conclusion, it doesn't guarantee that you're going to have the same truth value for both.